So we just defined the equation of the plane like this. Vector equation of the plane, which looks strange, right? So when you imagine the vector, when you imagine the equation of the plane, you probably imagine something like this, right? When we talk about the equation of the line, in general, it has the form ax plus by is equal to the c, right? So if you know some of the inputs x, you can find a y easily from here, from this equation, right? Just input some x, it is going to give you y, and you can find the points on this line, right? Okay, so now I would like to find all the points on the plane. Okay, so just knowing that the equation of the line is equal to the ax plus by is equal to the c. What do you think? How should be the equation of the plane? Which is more easier way to define the equation of the plane? Maybe ax plus by plus cz is equal to the d? Yes? This is more intuitive, right? Okay, so let's show that this equation, the vector equation of the plane, is exactly the same as this one. Okay? So what we're given the coordinates of one of the points, right? So R0 is given. What are the components of the R0? Do you remember when we talk about the position vectors, the components of the vector is just the coordinates of the ending point of the vector, right? What is the coordinates of the ending point of the R0? So you don't see this from the picture. It is P0. Do you remember? Right? It is given, right? So this is X0, Y0, and Z0, right? Okay, so what are the coordinates of the R? It is going to be simply X, Y, and Z. So any point on the plane, right? So when you write down the R minus R0, if you subtract the two vectors, or let's do this operation first of all. If you subtract the two vectors and multiply this to the n, right, is equal to the 0. From the properties of the dot product, we know that we can multiply each vector to the n separately as a dot product, right? It's going to be r multiplied to the n as a dot product minus r0 multiplied to the n as a dot product is equal to the 0, right? From here, we can get an equation r multiplied to the n is equal to the r0 multiplied to the n, right? Okay, so let's write down the component-wise the vectors. So the vector r has the components x, y, and z. Is multiplied as a dot product to the vector n. Do you remember the vector n is the, okay, so everything is erased. So the vector n is a normal vector. It has the three components, a, b, and c, right? So the vector n has the three components, a, b, and c. And at the same time, r0 has the components x0, y0, and z0. And the n has the, again, three components, a, b, and c. If you multiply this vector to this one as a dot product, what kind of result you're going to have? It's going to be ax plus by plus cz, right, is equal to, if you multiply this vector to this one, it's going to be ax0 plus by0 plus cz0, right? So probably you can define this as ax plus by plus cz is equal to the d, where d is some constant. And indeed, this is the constant, right? So your point is given was the constant coordinates, x0, y0, z0. And your normal vector is also given was the constant components, a, b, and c, right? If you just multiply them, and if you denote them as a d, this is going to be just one constant d, right? Actually, I mean, yes? So r minus r0 dot product to the n is equal to the 0 is the same as this one. Okay? So if I give you just the equation of the plane, so what are you saying? Is it real or is it easy to figure out the coordinates of the normal vector to the plane? Right? So first of all, so before we're given a plane, right? And I would like to know the equation of the plane like this, and I would like to know the coordinates of the normal. What is saying? What are the coordinates of the normal? A, B, C, right? So if you're given the equation of the plane, the coordinates of the normal vector is very easy to trace. It's going to be the coefficient before x, y, and z. Okay? Good. Let's do couple of examples. Easy example. So let's say we're find the equation of the plane which is going through the point with the coordinates t, 4, minus 1, with the normal vector n is equal to the 2, 3, and 4. Okay? So you can just substitute everything to this formula, right? It is going to be A, B, and C are 2, 3, and 4 are just the components of the normal vector, right? So what are the x0, y0, and z0? 2, 4, minus 1, right? First of all, we can find a d. D is going to be equal to the ax0 plus by0 plus cz0, right? It is going to be 4 plus 12 minus 4. It's going to be simply 12, right? And by just substituting a, b, and c instead of the 3 letters, we can easily get the equation of the plane, right? It's going to be 2x plus 3y plus 4z is equal to the 12 is the equation of the plane, which is passing through the point with the coordinates 2, 4, and minus 1, and which has a normal vector with the coordinates 2, 3, and 4.